The complex number system is a set of numbers that are made up of two parts, a real part and an imaginary part. So, a complex number is a number of the form a plus bi. It is of the form a plus bi, where a is a real number of some sort, and that part we call the real part. B is a real number with the letter I, the imaginary unit. Remember, that means the square root of -1. So we've taken the square root of a negative for this part as the imaginary part. So a complex number is two things, a plus bi. I always think of it as number plus number I. That is a single complex number. So let's look at a couple of examples here. A complex number is in standard form if it is literally of the form number plus number I. So let's start with this guy right here. Is there a number plus or minus a number I? Yes, this is a complex number in standard form. What about this one? That's actually a pretty simple one. Number plus or minus a number I. That is definitely a complex number. This -2 minus 3i is also a pretty clear one. One that's a little bit more confusing, but definitely a complex number is this guy right here, -3/7 plus the square root of 13 over 5i. I know this is ugly, but is it a number plus or minus another number, I? I didn't say the numbers had to be pretty. I just said they had to be a number. And that is actually a complex number in standard form. Similarly, over here, I know pi is not a number that we normally think of, but it is a number. It is a real number. So 1/2 minus pi I is also a complex number. Now you've noticed that I've ignored two of these numbers so far. Is this square root of 3i a complex number? It is. What we want to do is think of this as 0 plus square root of 3i, but why would we bother writing the 0? It's there, but do I need to write it? I don't. So this is a complex number. It has an imaginary part and the real part is 0. And most students kind of look at that and go, okay, so I just don't have to write the real 0. That seems like a complex number. The really tricky one is this first one up here, the number 9. Is this a complex number? It is. The real numbers are a subset or a group within the complex numbers. I can turn any real number into a complex number like this. If I think of it as 9 plus 0i, where the imaginary part is 0, and I just don't write it, then every real number can be written as a complex number. So all of these that we have seen are complex numbers that are in standard form. The problem we're going to have is if we remember our last video, sometimes we're going to get answers out of things that look like this guy right here. Is that in standard form? Well, if you ignore the plus or minus and just make it a plus for a second, it's still not in standard form because what we have is number plus or minus number I divided by 4. I didn't say you could divide. It has to be just number plus or minus number I. So how can we turn this kind of ugly looking answer into a complex number in standard form? That's what we're going to want to be able to do next. And to do that, we need to use a quick little trick that we may not think about normally, but we know how to add fractions, right? How do you add fractions? So how do I add 3/12 plus 4/12? Well, you add across the top and keep the denominator the same, right? So we add that 3 plus 4 and the denominator stays 12. And so then we would get 7/12. We're pretty used to doing that, right? So what we want to do is think, well, if this left-hand side equals this right-hand side, if those two things are equal, then why can't I reverse the process and say 3 plus 4 over 12 is also equal to 3 over 12 plus 4 over 12? Think about reversing that whole addition with common denominators. I call this uncommon denominatoring. You're taking that idea that we used with common denominators and pushing it backwards so that we can turn one fraction into two fractions as opposed to what we normally do. So, how does that help us with the problem that we need, where we need to take a complex number divided by something and put it in standard form? Well, the quickest way to do this is uncommon denominator it, just like we did here. So we're going to turn this into 3 over that 12 plus 4 over 12, and we'll put the I last. It's going to have to go last. My open math will mark it wrong if you put it in the numerator, so put it last, but it's the same thing. And then all I have to do is reduce these fractions. So this is going to be 1/4 plus 1/3 I. Is this now in standard form? Yes, it is. So we're going to use this trick where if you have a denominator under two things that are added, and that denominator is just a single number, you can pull it apart like we used addition, but reverse the process and give yourselves something in standard form. Okay, so let's look at this problem next right here, 3 plus 5i over 8. How would I uncommon denominator this so that it is in standard form? Well, I'm going to put the 8 under the 3 and the 8 under the 5. And now are we in the form number plus number I? Check. We're good. All right, let's look at our next one here. We're going to take that 6 and uncommon denominator it. So we're going to get 4 over 6 minus 12 over 6i. This one, those two fractions will reduce. We do need to reduce those. So 4, 6, those are both divisible by 2. This gives me 2/3. 12 divided by 6 is 2. And then we have an I. We are in standard form and fully reduced. Go ahead and give this next one a try right here on your own. So again, we're going to uncommon denominator it. And this first guy will reduce. Everything is divisible by 7, but the second one will not. And sometimes that happens. So we get that in standard form. And you'll notice I skipped one. What about this guy? Is this in standard form? Is that number plus or minus number I? No, it is not. Now, what happens is that a lot of my students will say, well, I just need to switch them. So this is going to be 2 minus 7i. And that is what a lot of students do. But if you look at this original question, is the 7 negative? No. Is the 2 negative? Yes. So be careful. The sign needs to stick with the number. So what I have here is incorrect. What I should use is -2 plus 7i. And that is now in standard form because it is in the form number plus or minus number I. So just be careful when you're switching those problems.